Alright guys, so what we're going to do in this video is talk about a cool result from the limit comparison test, and this is what's called the leading terms test for series, or at least that's what I call it. I don't know if it's actually the real name or whatever. So the leading terms test for series, and this is what it says, and this really is just a corollary of the limit comparison test and a shortcut that you can take in some cases. So if you have an infinite series that is a polynomial divided by another polynomial, what the leading terms test says is that this series will have the same behavior, meaning it'll converge or diverge in the same way. It'll have the same behavior as the series with the leading terms. And that'd be the leading term on top and then the leading term on bottom. Okay. And when you look at the leading terms over the leading terms, what that's going to be is it's always going to be a p-series once you do that comparison. Okay, so let me give some examples of what this will look like. And this is a pretty powerful rule, but it basically just says that if you look at the sum of 1 divided by n cubed minus 1, this is basically just going to do the same thing as 1 over n cubed, which hopefully is what you'd expect, because as we get to big numbers, 1 over n cubed minus 1 is pretty close to 1 over n cubed. So what this is saying is if you just take the leading terms, like let's circle those. So this series has the same behavior as just the series of 1 over n cubed. Well, we know that this is a p-series. The p is equal to 3, so of course that's bigger than 1, so we know it converges. So because I'm comparing it to the series that converges, that means this series will also converge. Okay, so that's the logic there. You're just saying, okay, I'm going to do some analysis on the series I compare to the leading terms, check it's a p-series, see if it converges or diverges, is p greater than 1 or less than or equal to 1, and then that'll tell you about the original series. Now, again, one thing worth noting out is the series are not necessarily equal to each other, so make sure you don't write that. But what we do know is that they both will converge or they both will diverge. That's the important part in doing these problems. Don't write that, if you write that 1 over n cubed minus 1 equals 1 over n cubed, like that's an easy way to lose a point or two on the AP test. So make sure you're not doing that. Okay, now next up, let's look at just 1 or 2 other cases where we use this leading terms test. So again, these questions a lot of time will ask whether the series converges or whether the series diverges. And we look at the sum of 3n plus 2 divided by 4n squared plus n plus 1. This is the sum from 0 to infinity. Okay, so again, take a gander at this and just say, all right, I have a polynomial on top, a polynomial on bottom. So I'm just going to circle the leading terms. And again, I'm not just taking a limit. It's not a limit, which is confusing because if we have a limit to infinity, we look at leading terms, but we're doing something similar here. But this is not a limit, but this just says this is going to have the same behavior as the series of 3n over 4n squared. Now again, I want to simplify this, right? So when I simplify, which I almost spelled correctly, I used to be so good at spelling. But when you simplify, you can cancel an n, and this is just the series of 3 over 4n, which is the same as the series 3/4 times 1 over n. Well, we know that the series 1 over n diverges because we've been paying attention at some point in the last 2 weeks. So what that means is the original series also diverges. Okay. So that's how this is going. One more thing is if you have a square root, I know we saw one like this on our homework a little while ago, but if we have the series of, say, 3n minus 2 divided by square root of 7 plus n cubed, we can kind of follow the same rules, but we want to make sure that we include that radical sign. Okay, so we're going to include that radical as part of it. So we're going to include the 3n and then the square root of n cubed. So the square root doesn't disappear when we look at the leading terms. This is the same as 3n over the square root of n cubed. So that's the same as 3n over n to the 3/2. I can subtract an n because that's like n to the 1 times n to the 1/2. So this is just the series of 3 over n to the 1/2. Okay, so this is a p-series. My p, of course, is 1/2. That power is less than 1. So, of course, that means that if p is less than 1, it diverges, which means the original series must also diverge. Okay, So that's the leading terms test. We can compare it to another series just knowing that that series converges, this one does too, or that series diverges, this one does too. But again, this is just a corollary from the limit comparison test. That's where all these come from. If you want to do it the long way and do the limit and just compare, like this series to the original series, it'll always work out correctly. It's just faster to say, hey, I can just look at leading terms. I know it'll do the same thing. Okay, so that's leading terms. Thanks for watching, guys, and I'll see you guys in the next video.